I'm going to go over both of these standards in one video. 4.05, I can use technology to determine an least squares regression line, which is, we did that in the previous problem as well. And then 4.06, I can write equations for upper and lower bounds and use them to create a range of predictions. So first thing, we're going to take this data and put it into Desmos. Okay, so I have my data in Desmos in a table. So I need to figure out what my least squares regression line is. So this data is y1 and x1. So we're going to go y1 squiggle m x1 plus b. Looks like it's a pretty good fit with a linear model. Okay, looks like our r squared 0.96, our r is 0.98. That's a very strong correlation. We've got my slope and we've got my y-intercept. We're going to go ahead and plot the residuals. We're going to need them later on. Okay. So first thing on the exam was to graph your data and to find the least squares regression line. So my least squares regression line is going to be y equals, I'm going to type it in here because I don't want to keep going back and forth to the paper copy. Y equals 2.08 x plus the b, which is negative 1.4. So why don't we just go minus 1.4? Okay, so there is my line. Okay, I'm going to go ahead and undo the residuals. Well, what are all these dots? Okay, so there is the answer to A, the least squares regression line. Okay, what would be the predicted output using Lenny's model for an input of x equals 30? So I'm going to go down here and type in x equals 30. And then we can see where that intersecting point is. So it looks like it's 61. So for problem B, the output would be 61. Okay. The other way you could have done that is just plug 30 in here, 2.08 times 30 minus 1.4, and you also would have gotten 61. Okay. Now, C says the actual value for an input of x equals 30 is 96. What is the residual for that data point? Okay, so the predicted model says it should be 61. The actual value is 96. So the difference between 96 minus 61 is 35. So that's what the residual is. So 61 is here, right? 61. And 96 is way up here. 96 would be up here. So the distance between 96 and 61 is 35. So the answer to C is 35. Okay. Now, the next question asks, if the output you're looking for is 20, what is the predicted input that will result in that output? So we want an output of 20. So instead of having an x equals 30, we want y equals 20. Okay, so we go down to where y is 20, and we check that out right there. And the input that we would need is 10.288. The other way we could have solved that is just taken this equation, set it equal to 20, and then solve that equation. Okay, so you can either figure these questions out graphically since you have Desmos, or you could use algebra. Just take this, plug 20 in for y, and solve for x. Okay, so those are the answers of 4.05. Now, 4.06 asked us to find the equation of the upper bound and the equation of the lower bound. Okay, so right now this is our least squares regression line. So to find the equation of the upper bound, what we're going to do is we're going to find the residual that has the highest, the most positive value. Okay, so let's see, 0.22, 0.46, 0.6. That is the largest positive value. Okay, and what we're going to do is we're going to add that number to the y-intercept. So we've got y equals 2.08 x minus 1.4, and then we're just going to add 0.6. Okay, so negative 1.4 plus 0.6, if you do that addition, it's negative 0.8. Okay, so that's the equation of my upper bound line. Okay, so that's the purple line. Now, if we want the lower bound, y equals 2.08x minus 1.4. Now we're going to subtract, right, the smallest value. So let's see here. This one here, we have negative 1.02. So we're going to go minus 1.02. Okay, and that's the black line, the lower bound. So if you do that actual addition, we get negative 2.42. Okay, so I just simplified those numbers. So that's the equation of the lower bound. Okay, now the last question on the test was use your least squares regression line, or the last question in the section, and your upper and lower bound equations to predict the output for an input of 27 and provide a range of outputs. So if x is 27, what is our range of outputs? So let's go over to, there's 27. Let's go up here and click here, here, and here. Okay, so the predicted value is this middle one. So let's look at this. How do I get that to go away? There we go. Our predicted value is 54.76. Okay. Our lower bound value is 55.36. Or excuse me, my upper bound. Wow, I'm really struggling here. 55.36 is our upper bound. Okay. Can't use my words this Sunday morning. My lower bound, 53.74. Okay, so now we have a range of 53.74 to 55.36 with a predicted value of 54.76 if the input is 27. Okay, that's how you use these equations. All right, if you didn't have Desmos to just click on these points, what you would have to do is you'd take 27 and you'd plug it in to the predicted model. You would plug it in to the upper bound model, and you would plug it into the lower bound model, get those values, and you would end up with the same answers. Okay, so written out, I'm going to show you the answers here. So here was the equation that we came up with, the least squares regression line, 2.08x minus 1.4. What would be the predicted output? So if you plug 61 in here, or excuse me, if you plug in 30 here, you get out 61, or you could look at the graph as we did. And the actual input for 30, the actual output is 96. So what is that residual? So we take the 96 and subtract the model's output. 96 minus 61 is 35. Okay. The output you're looking for is 20. What's the predicted input? So you could look at your graph in Desmos, or you could take 2.08x minus 1.4, set it equal to 20, and solve that equation, and you would get 10.288. All right. Written answers here. Again, these are straight from Desmos. Upper bound 2.08x minus 0.8. Lower bound 2.08x minus 2.24. Remember, we added the largest residual here. We subtracted the smallest residual there. And then part C, we've got, we want the least squares regression line output, the upper and lower bound output for an input of 27. So when we used our models from above, the lower bound output was 53.74. Predicted value, the least squares regression line, was 54.76. The upper bound output was 55.36. So, complete sentence. For an input of 27, you would expect a range between 53.74 and 55.36 with a predicted value of 54.76 as an output.